Here we go again. We are doing the second part of Chapter 6. We're at the top of page 406, and we are going to discuss the ambiguous case where we have, in any given triangle, using the law of sines, we have a side, and an angle that is not included between the two sides. This is called the ambiguous case. And it says, any two angles on a side determine a unique triangle. However, if the two sides and the opposite angle are given, then three possible situations can occur. And we're going to go over those here with our handy-dandy little swing A. In the box on page 406, it says, consider a triangle in which you are given A, B, so side A, side B, and angle A. In the first case we're going to look at, and before we start that, it says, notice that H is equal to B sine A. So I just wanted to draw your attention to that down here. The sine of angle A is opposite over hypotenuse. So sine of A is equal to H over B. Hence, H, multiplying both sides by B, H is equal to B times the sine of A. So I just wanted to make sure that that was clear to you, how they got that. We're going to be using this little fact here shortly. So, given this triangle at the top, the first case we want to look at, this side A is less than the value H. So we do know that any triangle, this height would be the absolute shortest side that we could have. What we're trying to do is compare that to A and look at the situations. So in the case where A is less than H, A is less than H, shorter than, we can see that if we take side A and swing it, it's never going to touch that base, and therefore we have no situations in which a triangle could exist. Okay? So that's none. A is less than H. None. Let's look at the next one. What if A equals H? Well, we can see again, if A equals H, there's exactly one situation in which we have a triangle, and it happens to be a right triangle. So if I take that side, and I knew what I was doing, if I take that side and now swing it, it's giving me the wrong one. If we were to swing that back and forth, we can see it's only going to touch in this exact point. So when A equals H, we know that we have one triangle that can be created. Let's see if we can get this back to where I need it. There we go. Okay. In the case where A is greater than or equal to the other side, B, let's look at that. We're going to take, I wish this thing could read my mind. Let's get rid of my dots. In the case where A is greater than or equal to B, let's line it up there. And we're going to make it bigger than that. We can see that that side swinging over here will create exactly one triangle. So this line at the bottom would extend. Nothing's going to cooperate with me this morning, so that's fine. It's 7 a.m. So you can understand what's going on. So when A is greater than B, we can see there exists a single triangle. And if we take A and swing it out here, and it's bigger than B, we can see it's going to go past that point and not touch that baseline again. So it's going to come over here and touch the extended part of this bottom line. So A greater than B or equal to, we have exactly one triangle. I had to get rid of some of our ink there. Let's look at this fourth case. It says the value A, the side A that we're looking at, is greater than H, so let's make it, but less than B. So if I swung that around there, it was bigger than H, but less than B. We see that one of our sides, in this case, could touch here, and then it could also touch here, making it possible to have two triangles that actually match that situation. So on the side where A is greater than H but less than B, we have two triangles that could be formed. So we're still at the top of 406, and I want you to pay attention to the fact that the first four examples we went over, A, that major angle A, was acute, and now we're looking at two different scenarios, both of which A is obtuse. So we have the first situation, A being less than B, and we can see if we grab that line. I wish I was better at that. I bet you do too. So if we grab that line and swing it around, we can see it's never ever going to touch that third side that we have. Second case for the obtuse angle, we have A greater than B, and with A being obtuse, we know that we can't swing back over here. If A is greater than B, here's B, we're going to make it bigger than. A needs to stay obtuse, so we can't come over here. That would create an acute angle at A. We need to stay over here. So we see that we have exactly one situation, one triangle, when A is greater than B, and none when A is less than B. So this is the ambiguous case using the law of sines when we have two sides and an angle that is unincluded. Let's go ahead and jump down to example 3. It says for the triangle, hang on, now we can see it for that. In example 3, we have a single solution case, side-side angle. For the triangle in this figure, A is 22 inches, B is 12, and we have the unincluded angle A, 42 degrees. Find the remaining side and angles. So using the law of sines, we can set up this proportion. The sine of angle B, the sine of B over the side B should be equal to the sine of A over the side of 22. Remember, we can use the reciprocals. First we had side over angle. Now we can do angle over side. So in solving this, we get the sine of B equal to, we're just going to cancel these out, times 12, both sides. We get angle B approximately 21.41 degrees. And then we can determine that angle C, big C, is approximately 180 minus A minus B. So that should give us 116. For C, we can see that it is obtuse, 116.59 degrees. Then the remaining side is given by C over the sine of C is equal to A over the sine of A, and then if we multiply both sides by the sine of C, those cancel. Multiplying by the sine of C, we get side C approximately 29.40 inches. Okay, let's look at problem 19, and then come back here for the solution. So problem 19 plays out like this. We have a triangle given angle A, obtuse, at 110 degrees. We have angle B and C unknown, and we have the two sides not included. not including the angle A. So side A 125, side B 100, and we set up our proportion, the sine of angle B over its side length 100 equals sine 110 over 125. I've simplified by multiplying both sides by 100, leaving the sine of B alone. So in calculating 100 times the sine of 110 over 125, we get this decimal value, and we might scratch our heads a little bit, but we know that we're just going to take the inverse sine of both sides. The inverse sine of sine cancels, and we end up with B. So the inverse sine of 0.75175 should give you approximately 48 degrees, 0.74. And so labeling our triangle 48.74 goes up here. 48.74 degrees. And then this little calculation down here, we're going to find the angle C, which I had not put in there correctly. We're going to find angle C to be roughly 21.26 degrees. And now we can set up our proportions for C, and we'll take a little shortcut here. C is A over the sine of A times the sine of C, big C. So in doing those calculations, we can quickly fill all of that in. We get 48.23, and I believe those were in, I don't know if we got the units for the sides. So we got side C is 48.23, and we have solved that triangle. Looking at example 4 at the top of page 407, it says, in the case where we have no solution in our ambiguous situation, in the case of side-side angle, we're going to look at show an angle where A is 15, B is 25, and big A is 85 degrees. Angle A is 85 degrees. So let's go ahead and show this. So we've got an acute situation, 85 degrees, and this is A, so opposite side would be 15. We can make this angle B, opposite side is 25, angle C, and small side C. So what we're going to do, the sine of B is 215 as the sine of A. Why am I'll tell you why. Sine of, let's start over, sorry, pardon me. The sine of B, the sine of B, which we don't know, is 225. Thank you. We're going to set that up with the ratio that we do know, the sine of angle A, 85, over the side length A. So we're going to go ahead and solve that proportion, finding the sine of B, which works out to be 1.6603, which is greater than 1. Now if you think about the range of the sine, the range goes from 0 to 1, and since this value is larger than that, we know that we have the ambiguous case, and there is no triangle for which this situation would be appropriate. So you could take inverse sine, just to prove it to yourself, and the inverse sine of both sides, and see that your calculator would actually give you an error. Let's try 47, and that will be on the next recording since they only go 15 minutes. So I'll meet you on 6 part 3 on Canvas. And you guys do problem 27, and that's where we'll go over the solution.